Welcome everybody. We are now going to talk about graphing logs. And by the way, my dog is right next to me drinking a bowl of water. So I don't know if you can hear that, but that's her drinking a bowl of water. Okay, but she's almost done, so I'll continue anyways. So here is our general format for graphing logs. We think of it like with this equation in mind. Y equals log base b in parentheses x minus h, and then outside plus k. And now this is cool because it follows along everything else that we've really done. So h is going to move it left or right, and k is going to move it up or down. In this situation, x equals h, and it's the opposite of what you see for h, is also a vertical asymptote. But the same rules apply as the other graphs we did. What I mean is, if it's a plus, it moves it left. If it's a minus, it moves it right. And for the k, if it's a plus, it moves it up. If it's a minus, it moves it down. I hope you're kind of getting to be experts at that knowledge right now. And I will show you more about this in a little bit. The domain of our log graph is always going to be x is greater than h. And the range is going to be all reals. And I want to just tell you that a log graph is an inverse of an exponential graph. So remember how an exponential graph had a domain all reals and a range x is greater than our asymptote. So this, or y is greater than the asymptote. So those two have just flip-flopped, and that's what happens when you do an inverse. All right, quick sketch. Depending on what the base is it depends on if it's an inverse of exponential growth or exponential decay. So if the base is greater than 1, it's going to look something like this. And right here would be the asymptote. If b is between 0 and 1, it goes this way instead. And the asymptote's still right next to it. And I'll say more as we graph. All right, here's what we're going to do for graphing. And I want to just tell you that actually graphing it, a lot of students struggle with this. So we're going to work together, and we'll do some more practice in class, because we're going to do 4 examples, but for a lot of you, 4 examples probably won't be enough. You might still feel confused at the end of this lesson, so we'll definitely work on this during class. But here's our steps. Write this down. Step 1, we're going to draw in our asymptote line. And remember, the asymptote line was x equals h, and it's the opposite of what you saw for h. So if I saw plus a number, it'd be a negative. So step 1, draw in an asymptote. Step 2, we're going to find 2 convenient points to plot. Find 2 convenient points to plot using your log knowledge. And I just want to throw it out there. Remember when we were doing the exponential graphs in 8.1 and 8.2, the 2 points that we found were 0, something, that was the y-intercept, and 1, something, that was some other point. We used those 2 because they were the 2 easiest points. This time we're going to have we're gonna also use that basically, only we're gonna have y as 0 and y as -1, and usually, and I'll say more about that in a little bit. But the recommended points that I would use are points such that I can make it so that I can use this property and that I can use this property. And that's not going to mean anything to you until I do the first example. But for now, just write this down. So I'm going to try to use the log base a of 1 equals 0 property and the log base a of a equals 1 property. Those are the 2 properties I'm going to try to use to find my 2 points. Step 3, we're going to plot our points and draw the sketch. According to what I just said earlier, where it could be b is greater than 1 or b is between 0 and 1, you just kind of have to draw it in depending on that. Alright, so let's do an example. So first of all, let's identify where the asymptote is. The asymptote is supposed to be the h value, but I don't see anything in there. This -1 is outside the parentheses, which means it's a k. If there was an h, it would be in the parentheses, such as it looks like for example b. That means there is no h value this time. And so really there is an h value, it's just 0. So I'm going to say there's, quote, no h, but really it's 0. Let me get myself set up here with my graph. That's just my xy coordinate plane drawn as best as I can. So I just said that x equals 0 is the asymptote. Notice that it's vertical this time. Asymptote x equals 0. And now here comes the hard part. So I am going to attempt to find 2 points. My first goal is to use the property where I have log base a of 1, because I know that that whole thing is going to be equal to 0. So this is me trying to do this if, let's say, didn't have a calculator or something. But this is a method you need to do, especially if you're going on to trig next year or next semester. Alright, so here's what this means. How do I make it so that there's a 1 right there? Well, because that's just x, that means I could put in a 1 for x. And here's what that means then. I just told you I'm going to put a 1 in for x. Now the reason I did that is because my property says anytime there's a 1 right here, that log statement is equal to 0. So now I have 0 minus 1, that's negative 1. So 1 comma negative 1 is my first point. Here's my other goal. I'm going to try to use the property where both of these are the same. The base and this number are the same, because if that's happening, then that's equal to 1. So if I look at what I've got, in order to make this right here the same thing as that base, I need to make it a 1/3. So for this point, I'm going to have it be 1/3 comma something that I'm going to figure out right now. All I had to do was finish the formula. I want to point out that what I did is I took this and I replaced x with a 1/3 this time. That's all I've done so far. Now the reason I did that is because, again, if these two things are the same, that whole entire log statement is equal to a 1, and so my answer for that is 0. So 1/3 comma 0 is the second point. Now my graph is going to look like this time, and that's it. That's as specific as we're getting. So that's it for there. Because b is between 0 and 1, I had it be this shape. And then the other thing we'll do really quick is let's find the domain and range. Remember I told you, so this time the domain is x is greater than the asymptote. What I mean is all of my x's are over here. I don't have any x's over in the other region. So all of my x's are going to be greater than 0. So my domain is x is greater than 0. And remember I said this time the range is all reals. And the reason is if you look at the y values, all of the y values are going to be used if I made the world's largest graph. And I can say more about that when we get to class. Okay, so if you didn't quite understand that, keep listening, keep paying attention, because you will get it eventually, but usually this topic does take students several examples. So when I do 2 examples of a log graph, it might not actually even be enough. You might not get it until we do this in class tomorrow, but that's okay. Keep listening, because you will get it eventually. So remember I said step 1, find our asymptote and plot it. Actually, step 1, I'm going to draw on my xy coordinate plane. Okay, there is my xy coordinate plane. Step 1, find my asymptote then. So when I said the opposite of what I see, if I see a +2, that means my asymptote is at -2. And basically, this makes sense, because remember how I said that moves it left? Basically, I'm moving my asymptote, which would normally be at 0, I'm moving my asymptote left 2 units. So the asymptote is at x equals -2 this time. Now I'm going to find my 2 points. So, first goal, I'm going to use this property. So what that means is I want to make this right here a 1. Now look at the formula we're given this time. You got to ask yourself, what do I plug in for x to make it so that this part right here is a 1? And so think back to the other problem. The other problem just had a plain x there, so all I had to do was plug in a 1. But now, in order to make this a 1, I need to plug in a -1 actually. So my first point, the x value is actually going to be -1. All right, then, in order to find the y value, I continue on, so I'm going to actually evaluate it, and the reason I chose -1 is this is now log base 5 of 1. Our property is anytime I have a 1 there, that whole thing is just equal to 0. And in this situation, there's nothing over here added or subtracted or whatever, so the answer is just 0 for the y value. -1 comma 0 is my first point for this graph. Here's our other goal this time. Well, actually, same as before, not this time. The other goal is to make it so that the base and this number are the same thing, because then I can have it equal to 1, so that again makes it easy. So let's take our formula this time. So again, I want to make it so that this part is the same number as 5, because that's what a is this time. So you got to ask yourself, what do I plug in to make this be a 5? And this time I plug in a 3. So the x value is 3. The reason I did that is that now I have log base 5 of 5, and whenever the number, the base and the number are the same, it's equal to 1. So 3 comma 1 is the second point. Now b is greater than 0 this time, or b is greater than 1 I mean, so the graph looks like this when I draw in my curve. Domain, x is greater than -2, and range, all reals. We're going to now move on to the natural log graphs, and this is actually, we're going to do it the same way, only it looks weird because of the e. So for part C, first goal, find my asymptote. You know what? I don't have a h value again. There's no parentheses, so my asymptote this time is again just at 0. So x equals 0 is my asymptote. There I go. Step 2, I'm going to use my two formulas. So the first one is to make this right here a 1. Right there, I want to make that a 1. So look at my thing I have. That's where the x was. What do I need to put in there to make it a 1? Well, because it's just by itself, I'm going to put a 1 in there. And remember, a ln log is the same as a log log. Same rules apply. So it might seem weird that I'm doing this, but same rules apply. So log base e of 1 is 0. That's why I wanted to do that. That means y is equal to 2. So my first point this time is 1 comma 2. To find my other point, I'm using this property. Log base a of a is equal to 1. Here's my formula, or my equation this time. So when I say log base a of a, I want this to be the same as this. Now the base happens to be e, so that means I want to put a e in here. Seems weird, but that's okay, because remember, e is really 2.72 approximately, or you know what, I'll just say 2.7. So if I put an e, really I'm saying x equals 2.7. That whole thing, because this and this are the same, that's equal to 1. And my y value this time is 3. So 2.7 comma 3 is my second point. There it is. Because it's a ln graph, the base was e, and e is 2.7. That is definitely greater than 1, so my shape looks like that. And I'm not going to do domain and range for these last two because I'm running out of time on this video. So I'm going to do as much as I can with part D, and if we run out of time, we'll finish it in class. So step 1, let's plot our asymptote. When I look at step 1, I see that it has a +2, so that means that my asymptote is moved left 2 units, so my asymptote is at -2. Now I'm going to find my 2 points. First goal is to try to make it so that this thing right here is a 1, because then that whole log will be equal to 0. So here's my formula this time. Alright, so I want this. I want to put something in there so that this parentheses is equal to 1. Well, to get it equal to 1, I need a -1. -1 plus 2 is 1. So x is -1 for my first point. Now to get y, anything, if I have a 1 there, that's equal to 0, so my y value is -1 for that first one. So -1, -1 is my first point.